Hey, everybody. I think that might be a little loud. I am the co-organizer of the San Francisco WebGL Meetup group. We meet regularly, and we have about 800 members, so we're pretty solid. We've reproduced recently. We have a Silicon Valley spin-off, so if you're actually based in the peninsula of Silicon Valley and want to go to meetups down there, look that one up on meetups as well. And we recently also created a WebVR Meetup group to talk about the topics that we're going to look into tonight. A year ago, almost to the day, I was up here on this stage, thanks to Peter and folks, and made the somewhat audacious claim that WebGL would be everywhere by the end of 2014. And guess what? I was right. We were right, and the people who believe and the folks who had been backing WebGL and investing their time and energy into it, our investments have been paid off big time. WebGL is on iOS 8 and up. Basically, it runs on every device, anything you can think of on the planet. 3 billion WebGL seats out there. That is awesome. What happened in 2014 was that there was some bigger piece of news, which is that virtual reality has hit the stage, as we all know, with Oculus being purchased by Facebook, sort of getting this thing to explode. And so what we're going to talk about today is how these technologies are on a quick convergence course. So how many people have had a chance to play with an Oculus Rift? Good, pretty good, about half of you. It looks like this if you haven't seen it. This is the latest developer kit. You can buy one for $350, not too bad, and you can build applications for it using their SDK, and we're going to get into how you build apps in a second. Have people heard of the Samsung Gear VR? So this was just released in December. Samsung did a partnership with Oculus. They licensed some of their technology, including the optics, for the distorted lenses to give you a mobile VR experience. I mean, Oculus is great, but you're actually connected with this cable, as at least the current editions here, and it's kind of clunky, and you have to hook it up to some big honkin' PC or the best Mac you can buy. It's it's not a very mobile solution. So Samsung's built this mobile thing, but it's a $200 headset, and right now you can only drop one phone into it, and that phone is the Samsung Galaxy Note 4. If you don't already have a Note 4 or weren't planning on buying a new phone and getting a new plan, you're talking about spending $800 on the phone plus your $200. So not exactly the low-cost kind of solution we might want yet, but it's really amazing. I needed a tax write-off at the end of 2014, so I said, okay, I'm going to splurge. So I bought a Note 4, I got my Samsung Gear VR, and this thing is awesome. The apps are beautiful. There's this wonderful little sort of channel changer, way to switch between apps. It's called the Oculus Store. And it's just beautifully designed. And I highly recommend you try one if you don't want to go out and buy one, because they do cost a lot of money. And then there's this thing called Google Cardboard. I don't know if the idea was, kind of a slap in the face to Oculus or whatever it was back a year ago or so when that acquisition happened. But shortly after Oculus was acquired by Facebook, Google at I/O last year came out with this thing, which is a little cardboard box that you can pop your smartphone into. The box costs about $2 in parts. Plastic lenses, cardboard tape, and then folks make them for about $20, $25. You can just buy the stuff ready to go to assemble, so you don't have to cut it and find all the pieces. And Dodo Case, the last speaker tonight, is going to show you Google Cardboard. So that's super cheap, and it works on any phone you got today. Now, it doesn't have quite the same wide field of view that an Oculus does. It doesn't track as fast, and you'll see all that. And it's more for the lightweight little tastes of VR, but it's kind of amazing that you can do all this for just a few dollars. So we have a lot of consumer VR potential here. Imagine Samsung Gear VR gets cheaper. Imagine Oculus gets their form factor together for the retail set they'll ship at some point. And imagine Google Cardboard sort of growing up to be maybe more durable cases you drop your phone into. So very exciting. But let's talk first about how VR apps are built today. And this is what's going to be interesting to the people in this room. If you go out and try and get an app for Oculus today, mostly what you're going to see is a site full of apps to download. And I mean apps, like 300 megabytes of stuff. If you're doing it on Samsung Gear VR, you actually have to go through an app store and do an install. When you build your VR, you're building it with a tool like Unity, and you've basically got a proprietary stack. Unity is great, and it even publishes to WebGL. That's a sidebar. We'll talk about that later if we have time. But mostly you're using proprietary tools. And in general, it's a closed culture of sort of game development style ways of building VR. And you need to be an expert in 3D graphics. This world we're seeing already is almost like console gaming and mobile computing, the mobile market have had an evil love child, and they're sort of replicating all of the things that we've been seeing with app stores that the mobile web is trying to undo. So it's a very interesting situation right now. And the folks in this room are here to try and offer a different alternative that's more like the web. And we know why we like the web. We like the web because we don't need to download apps. Someone sends you a URL, you hit the link, and you see the page, right? There's nobody gatekeeping. You don't have to install an app. When you're creating your content, you can publish it instantly in the cloud, and you can use any choice of tools and open source technologies to build things. So it's a very different world. And in general, this is a world with no barriers to entry. So imagine, everyone loves VR now. People are super excited about it. I go to these VR meetups, and 90% of the people in the room are not Unity developers. They're not game developers. They want VR to go visit other places, to go take a walk through a Tuscan village, to go do an architectural recreation or historical recreation for somebody. And guess what? Most of the people that do these kind of things don't actually have any money. Let's say you're the Museum of Science in some town, Poughkeepsie, New York. I don't know if they have a Museum of Science, it's just a guess. And you have, you want to build a little planetarium exhibit. You've got 2 people, 2 months, and no money. So you can't hire a game development team to build this stuff for you. So, imagine if we could bring together the web and VR. Maybe we can have the chocolate and peanut butter, the Reese's cup, if you will, of this kind of new experience, which is virtual reality created with open web technologies. And that's what WebVR is all about. With WebVR, you build your apps in JavaScript. And they render in WebGL, which is everywhere now, like I said. Now, what we're going to see tonight is that there are new builds of the browsers. If you go, we have links for this. You can go get builds of Firefox and Chrome that have VR support. That's essentially 2 things. It will head track the Oculus Rift rotation. And this could work on other headsets too, but it's being built for Rift right now because that's the predominant one. And it will do the stereo rendering and distortion if you go into full screen mode that you've seen, like we see up here. That's what your actual image looks like until it's assembled, in the Rift for your eyes. So the browser will do this stuff for you automatically in a full screen mode. What does that mean? Let's assume someday the browsers just have these features built in. You no longer have to go to an app store to experience VR. You no longer have to download an app. Now with mobile and Cardboard, we can just add a smartphone. This actually works with today's browsers. All you need to do is WebGL rendering 2 images side by side, not even with the distortion, and just use the regular device orientation that comes with your phone and that works in a browser. And you can do it in a browser or in a hybrid HTML5 mobile app, like with some native code around it if you want to make an app instead. So there's a site up there. Josh, who's the next speaker, is actually going to show you this stuff in a minute, so I won't get into it. But Mozilla VR was the first out there with this. And here's the awesome thing is that Mozilla and the Google team are kind of working in lockstep on this. They have the same APIs they're building to. So this site will work with the Google Nightlies as well. But if you go to mozvr.com, you're going to see some wonderful experiments of a first attempt at visualizations using virtual reality. This is a screenshot from a project I worked on, myself and a fellow named Eric Levin, who's a creative coder in the city. And we built this thing working with Josh Carpenter from Mozilla to basically do a fly-through of an information landscape. And then Josh put a really nice front end together with his creative team to basically give you a way to navigate from VR scene to VR scene. And I think he's going to show you that in his next talk. So real quickly, and Brandon's going to go into details on this tonight, we're going to talk about the API itself. As I said, it's the same API. It runs in both of these browsers right now. I hope other browsers will support it at some point. What you do in your JavaScript code is the first thing you do is ask the browser, navigator.method name. Brandon will show you later, I've forgotten. Get VR devices, is that right? And you get a call back from that method, and it's going to give you an enumerated list of the VR devices you have at your disposal. So if an Oculus Rift is connected, it's going to tell you. And it's going to give you a device for doing the stereo display, and it's going to give you a separate device for the positional tracking. And you're going to use those in your JavaScript code to render and track respectively. If you find the VR device for rendering, you do a set full screen on it. Just like the set full screen API, you already know if you've done full screen HTML, but you pass it a VR device as one of the arguments. And then during your request animation frame loop, everyone knows what request animation frame is at this point in 2015? Yes? No? Hope so. Anyway, when you're doing your animation, that's when you want to actually query the device and find out the latest position and orientation the Oculus Rift, the DK2 will actually track position if you mount a camera on your computer. And if you're like me and you don't want to code in WebGL all day long because it's a hard API to use, you're going to use a library like 3JS. 3JS actually has 2 objects that come with the samples now from version 68 and up, where you can just go get sample code that gives you the stereo rendering effect and the tracking controls. So that's pretty awesome. It's even easier with Cardboard. So here's some links, and I'll have these slides up online so you can see the Google Cardboard showcase if you haven't checked it out, Chrome VR. Like I said, you just render the images side by side. So what that means really, if you don't know your 3D, is you have 2 cameras. You point the camera at the scene from one place, and then you offset it, well, just exactly the distance your eyes would be, or most people's eyes would be, which is about 6 centimeters-ish. Anyway, you draw the scene from 2 cameras. So you render that on each side here. These are 2 images from the gallery that was created by Mr. Doob, fellow who wrote 3JS. And that's a way to navigate through different scenes. When you look at a tile, that little cursor will tick down and launch your application. So that's there. And all you have to do is that and use the device orientation API to actually track where the camera's looking. And that's it. And Google was giving out cardboards out front there, so I hope you guys got those if you haven't already. And the folks from DodoCase make a really great cardboard viewer. And there's about 500,000 of them out there or something. So, you know, people are picking up on these and they really like them. So, you know, that's kind of it. The rest of the speakers are going to get into some details for you, but I want to kind of speak to you about some of the challenges and where I think we are at. So when you play with WebVR and the Oculus Rift, I think you'll agree, you're going to see some of these experiences tonight. They're kind of experimental, not quite ready for prime time, but it's okay, neither is the Oculus Rift. Apparently, they're not going to ship a commercial headset till about 2016 is the latest. Early 2016, I'm hearing, and then I've heard late 2015 at CES recently. Maybe they're hedging now, but it's not going to be for a while. If they say early 2016, you know it's not going to be a day before that. So we've got some time, and you know, presumably the browsers will just get better and keep tracking with that. We're still seeing issues with latency. So one of the big things about virtual reality, if you've tried an Oculus Rift, is especially the lower res ones and the slower ones, like the earlier developer kit 1, is that as you turn your head, if the image isn't catching up with you, you can get a kind of motion sickness. So the real goal in application development is to get to 75 or 90 or even 120 frames per second now, is what the folks from Oculus are saying is a good responsive VR application that makes you feel like you're always there. So current browsers, just you got to kind of sync your browser up, otherwise you get really janky effects, and that's it's throttled to 60 frames a second. Brandon, did you guys fix that yet?
In some cases, I'll talk about it.
Yeah, so Brandon's going to talk about where they're at on that, but if we can unleash that and essentially get rid of this artificial barrier to frame rate, then that'll be we're going to be in a better position to render VR apps fast enough to have a good experience. And of course, we get clunky software installation and drivers and all kinds of installs, and hopefully a lot of that's going to get cleaned up. With Gear VR, to build WebVR today, I've been seeing things on the mailing list that are out there. People are starting to try that. I just bought my Gear VR, so I'm going to try it soon, which is to be able to put together WebVR into the Gear. But you got to do it with a hybrid application, because the Gear VR actually has a separate motion sensor. It doesn't use the one that's built into the phone, the accelerometer of the phone. So if you use the device orientation API that comes in your browser, you're not getting the right sensor. You need to actually talk to the other one. So what you would do is you build a hybrid app. You build native code that talks to that sensor using the Oculus SDK for mobile. And then you'd render with WebGL using all your HTML5. So most of your app could be written in HTML5. I don't know how well this is going to work. I hope to be able to report on this in the next couple of months. I'm actually going to start working on it. Cardboard's ready to go, actually. This is the fun thing, though. The 500,000 headsets out there, that's going to grow and grow and grow, because people are doing things like advertising stunts with it. They're, you know, taping at concerts. There was this Paul McCartney concert that was just done and a Jack White concert filmed in VR. So it's just stereo video. It's not interactive graphics, just video, but viewable in Cardboard. And they've just given away a bunch of these things at events. And so we're going to see more and more of these Cardboard viewers out there. And I think that's a really exciting way for all of us to get started on VR, where it can get in everybody's hands this year. So that's really great. One of the big challenges on VR right now is input. So if you have tried an Oculus Rift, I won't put this on because I got this mic on, but if you tried it on, you got this thing on your head, you are now blocked off from the outside world. And if you've done a lot of these Oculus demos, a friend of yours is taking your hand and like putting it on the WASD keys, or like putting a game controller in your hand. And we all know how to use, I think, an Xbox or PS4 controller now, so that's the good news. But putting that in your hands, or as David's going to show you tonight, there's leap motion input that's starting to happen, but it's pretty challenging still. We don't have the mouse of VR yet. And so, we're literally flying blind when we strap into these devices. And so that's going to be an interesting area over the next few years, and one where the browsers could be challenged only because browsers don't have a kind of generic way to get input from devices via USB. So we're gonna get into a situation there, but let's take it as it comes. And the tools are really rough. There aren't really good development tools for WebGL yet, and that's where the sort of rubber hits the road. I'm going to just quickly tell you about a project I'm working on. It's called GLAM for GL and markup. So I've actually made it so that you can just use markup tags in CSS to make 3D scenes. And so there's the GitHub repo. You can go check it out, or check out the demos at glamjs.org. And it's literally to make a scene like this with a panoramic background and bubbles that you can click on and they go pop. It's really sweet. You just do this much CSS, this much markup, and there was I wrote about 20 lines of JavaScript code to randomly place bubbles. So instead of doing it, if you've done 3JS development, it's lines and lines of code to just kind of string together your scenes. I thought it would be really, really good to have a declarative markup way of doing this. And turns out I wasn't the only one. There's another project out there called Scene VR, and this guy Ben Nolan and I are talking right now to see if we can just use the same set of tags. So that's pretty exciting out there on the tools front. But we're still new and evolving. I mean, I got to admit, the situation on native app development for VR is much better because you've got a tool like Unity that's really ready to go. Whereas in the open web, you're going to be stringing together a bunch of things with 3JS and building your own tools pipeline. But I promise that will get better over the years. These are going to be up on SlideShare, so you get a list here. I made a quick set of examples that are up on GitHub that are just simple 3JS and JavaScript for making WebVR. Here's the links for the browser dev builds. These are not in the nightly channels yet. Josh, has that changed? Okay, Josh will tell you about where Firefox is on this, but so you have to go get a specific build. It's not the Chromium Nightly or the Firefox Nightly yet. That Moz VR showcase, Josh is going to show you, and the Cardboard VR showcase. And then there's a mailing list. If you really want to get into these subjects, go to WebVR Discuss, subscribe to that, and there's, I don't know, it's not too noisy right now, a handful of messages every day, really exciting chatter. And then one quick announcement, and my friends in the room probably, this is the time where they're going to come up and examine my head. But I've just signed up to write my third O'Reilly book, and we're going to try and get it out roughly in May, and probably early release for Fluent, which is in April this year. And this is going to be a very high-level book, and it's also going to talk about native and WebVR stuff. So unabashed plug for this, but if people want to get into this more fully, this would be a great place to start. Or if people want to help me write and review the book, come find me afterwards. I'm really excited about this one, bringing the word to the world. All right, so with that, I'm pretty much done. So I would love to bring Josh up here. You ready, Josh? Yeah, sort of? Good. All right.
Yeah, good? Okay.
We need to switch up video, right?
I'll take that.
So back in around May last year, after that Oculus announcement, there was the first virtual reality conference in Silicon Valley. It was called the Silicon Valley VR Conference. And I met this fellow, Josh Carpenter, and he came to me and he said, we think this Oculus stuff is great. We're thinking about building support into our browser. What do you think of that? I said, that sounds like a really good idea. And so we stayed in touch on that, and 2 months later, Josh showed up at our WebGL Meetup and showed off an early version of this running in Firefox. And guess what? Brandon Jones from Chrome also showed up at the very same meetup and showed the same stuff running in a Chrome build. So we're talking already 6 months ago, those folks have been trying to get their APIs working together, and WebVR working in both browsers. So that's a real testament to collaboration, and it's been amazing working with these guys. So Josh, are you ready?